On numbers 7 and 9, what we're doing is simplifying or evaluating expressions. So number 7, don't be fooled here because this is not an equation. A lot of people see this and they start using their rules for equations, but this is just one long expression that we're trying to simplify. In this case, it means that we need to distribute the 4 and distribute the 3, and then whatever results we're going to combine like terms with. So 4 times a would be 4a. 4 times 2b would be 8b. Since it's positive, we'll write that as plus 2b. When we're distributing the 3, we're going to include this minus sign with it, treat it as a negative 3. So negative 3 times 4a would be negative 12a. So I'm going to write that as minus 12a. Negative 3 times negative b would be positive 3b, so plus 3b. At that point, we're ready to combine terms that we would call like terms. Again, like terms are any terms that have the same variables and exponents. So 4a minus 12a. And then we can say positive 2b plus 3b. So those terms that are underlined in the same colors can be either added or subtracted depending on what they say. So 4a minus 12a would give us negative 8a, and 2b plus 3b gives us positive 5b, so plus 5b. At this point, we don't have any more like terms, so this would be our answer to number 7. On number 9, we're evaluating this expression for c equals negative 3 and d equals 4. There's one point or one spot in this problem that has caused some issues for people up to this point in the year. When we see c squared, this means c times itself. If our c value is negative 3, then I want to say negative 3 times negative 3. So I do not want to write that as negative 3 squared. When we enter this in our calculator, it thinks that we want to say 3 times 3 and then whatever we get make negative. But in reality, we want to say negative 3 times itself. So a good rule of thumb is if you're evaluating an expression, whatever value you substitute in for a variable, go ahead and put it in parentheses and then you'll always be in good shape. So minus c, so minus negative 3 times d, which is 4. And then we'll simplify this expression using the order of operations. Negative 3 squared is positive 9, so 9 minus negative 12. 9 minus negative 12 is 21. So number 9 would be 21. Looking at the next section, we have an absolute value inequality. So if we solve this inequality, we can think about this as, we can set up two inequalities. The expression inside the absolute value bars has to be less than 7 units away from 0 on the number line. What that means is really that it could be less than 7 units away, or it needs to be greater than negative 7. So that, again, that expression, because I just kind of stumbled over my words, x minus 2 needs to be less than 7, but it also needs to be greater than negative 7. So we'll solve these two inequalities. So we'll add 2 to the left and the right so that the 2's will add to equal 0. So x is less than 9. Add 2 to the left and add 2 to the right, and that's going to give us x is greater than negative 5. So our solution is x is less than 9 and x is greater than negative 5. So if we graphed that, we know we're going to plot both of those points on the number line. Since our negative 5 is less than 9, we'll put it on the left, and we'll put the positive 9 on the right. Since our inequality symbols are just less than, they're not less than or equal to, we're going to have open dots on those points, and then we need to decide if we're going to shade between those points or if we're going to shade on the outside of those points. One way of remembering that is looking at the inequality symbol at the point where you have the part inside the absolute value bars by itself. Since this says less than, just a way I told you to remember that is less than, little, shade in the middle. So I'm going to shade everything between negative 5 and 9. Alright, now then we've talked about a way of looking at this on the calculator. Again, this is not mathematically sound. It's not a good way of thinking about it apart from just confirming that you have a right answer. So this works out every time, but it is not a way of solving an inequality. Please don't just say, I typed this in on the calculator. but we can confirm that our graph looks the way it should by going to y equals and clearing out whatever's in there, and then I want to enter the absolute value of x minus 2. Well, we can get to the absolute value bars on our calculator by hitting Math and then going over to the second column that says Number and choosing the first option that says ABS. That's absolute value. Since the x minus 2 is in inside our bars, then I'm going to say absolute value of x minus 2 and then close our parentheses around the x minus 2. So whatever's inside the bars is going to go inside parentheses. Then we're going to enter less than. Well, to get to the inequality symbols on our calculator, right above the Math button we see the word test. We want to pick that function. So second Math to get to test, and then our fifth option down says less than. So number 5 and then 7. So when we are typing an inequality into our calculator, we're going to enter the entire inequality into y1. The entire thing, including the left-hand side, the inequality symbol, and the right-hand side. When we hit graph, we're going to see a graph that looks like this. It's kind of tough to tell, but it looks like our inequality, the graph of our inequality is stretching from -5 all the way to +9 and shaded in between. If it had said greater than instead of less than, then this is what it would have come out looking like. Again, this is not part of the problem. I'm just showing you what it would look like if it had said greater than instead. In that case, it would shade to the outside. So that's just another way of helping you confirm that you solved these problems correctly. So our graph should look like this. Again, they're open dots since our inequality symbol just said less than. If we look at number 13, we need to solve that inequality, and this is not an absolute value inequality, which means that we're not going to need to set up two inequalities. Well, we can solve this just as we would solve an equation, just remembering that if we divide by a negative number at any point on both sides of the inequality, we need to flip the inequality symbol. So our first step would be to subtract 4 from the left and the right so that the 4's cancel. That's going to give us -6x is less than -6, and then to get x by itself, we'll divide both sides by -6. -6 divided by itself gives us +1, so +1x, or just x. On the right hand side we get +1, and again, since we divided by a negative number, then we're going to change the inequality symbol from less than to greater than. So if we were to put that on a graph, well, this is a little bit different than the previous problem we looked at, because now we only have one number that is going to appear on the graph, and that number is going to be 1. Since this just says greater than, it's not greater than or equal to, we're going to have an open dot on that 1, and then we're going to shade all of the numbers that are greater than 1. So I'm going to shade to the right, because as we move to the right on the number line, our numbers are increasing. We can confirm that answer again on the calculator by typing the entire inequality all into y1 on the calculator. So clear out whatever's in there, and then I'm going to type in -6x plus 4. Second Math to get to our inequality symbols. Choose the less than option, number 5, less than -2. When we hit graph, it looks like our graph is going all the way from +1 on to infinity. And if we pull up the table, we can see that as well. When our x value is 0, it looks like our graph hadn't really started, so it's at 0 too. But it looks like when we get past 1 or greater than 1, our graph moved up one spot from the x-axis up one place. And then if we increase our x's as far as we want, we're going to see that our that our y values are still 1. So again, looking at the graph, that means that it moved up from the x-axis up one space and stayed up there. So that just is a way for us to confirm our answer on 13. Looking at the next section, now we're solving equations. The way that we solve equations using the calculator, again, this is not mathematically sound. It's not the way that I've taught you. This is a way to check your answers. So this is a way of knowing for sure that what you've done by hand is correct. If I wanted to solve these by hand, we've talked about a 4-step process throughout the year. Our first step is to use the distributive property if that's necessary anywhere. 2 times 5x is 10x. 2 times -12 is -24. 6 times -2x is -12x. 6 times 3 is 18, so plus 18. plus 2. Our second step is we said we were going to combine any like terms that we see on the left-hand side or the right-hand side. Well, there are like terms right here. 18 plus 2 gives us 20. So what that leaves us with is 10x minus 24 equals negative 12x plus 20. At that point, then we want to get rid of the x's on one side or the other. Where we see a positive 10x on the left and negative 12x on the right, I like to deal with positive, so I'm going to get rid of the negative by adding 12x to the right and adding 12x to the left. Once we've done that, the negative 12x plus 12x adds to give us 0, so that's going to leave us with 24x minus 24. Sorry, that should be 22x minus 24 equals 20. Then we'll add 24 to the left and the right, and once we've done that, the 24s are going to add to give us 0, so we'll end up with 22x equals 44. We'll divide the left by 22, we'll divide the right by 22, and that's going to give us x equals 2. Okay, now a lot of us are very good at solving equations. We can do 1, 2, 3, 4, 5, 6, 7 steps worth of work and get the correct answer. But if that's not something that you're comfortable on, or if you just want to confirm that what you've done is correct, then what we can do with an equation, we're going to enter this a little bit different than with an inequality. We're going to enter the left-hand side of the equation into y1. We're going to enter the right-hand side of the equation into y2. And then just like we found the intersection on our system of equations, we want to find the intersection of the two resulting lines. So turn your calculator on, hit the y equals button, and then type the left-hand side exactly as it appears into y1. 2 times 5x minus 12, close parentheses, go down to y2, enter the left-hand side, 6 parentheses, negative 2x plus 3, close parentheses, plus 2. When we hit graph, we're going to see two lines that intersect. If we don't see the intersection on the screen, it's not a big deal. The calculator knows where they intersect. What we want to know is, where do they intersect? What is the x value where they intersect? So I'm going to hit second trace and then choose option 5 where it says intersect, and hit enter once, enter twice, enter a third time, and the x coordinate that they give us is 2. Now, a lot of people have said that takes too long for us to type all that in. Once you've done it a few times, it's going to be faster. And again, I want to emphasize that that is not a way that I'm teaching you to solve problems, but it is a way that is going to confirm your answer, whether you've gotten it correct or whether you've missed it. So please be sure that you use that method also. Looking at this section, now we're just this is some definitions and some facts that we've talked about throughout this chapter. Number 19, it says blank lines have the same slopes. We've said that parallel lines have the same slopes. A system of intersecting lines has one solution. It's the point where they cross. A system of parallel lines has no solutions. That should say no, not none. A system of equations which represent the same line has infinite solutions. The graph of the inequality x is greater than 2 will be a vertical line, and the graph of the inequality y is less than or equal to 3 will be a horizontal line. Looking at the last section, we had one that looked like this. Our numbers 1 through 6 from our homework 2 nights ago looked like this. The only difference is that the equations that are graphed now are already solved for y. So the directions say to use the graphs at the right to determine whether each system has one solution, no solution, or infinitely many solutions. If the system has one solution, then we want to name it. So this equation is already graphed over here. The difference is in the way that it's labeled over here and here is that this equation is not already solved for y. So let's solve that for y by subtracting x from both sides, which is going to give us the equation y equals negative x minus 3. Well, if I find that line, I'm going to highlight it in red over here. The equation y equals negative x minus 3 is right here. What we're wanting to do is to now find the second line that we're given in this problem. So I need to solve for y, so minus 2x to where these cancel. That's going to give us negative y equals negative 2x minus 3, and then divide both sides by negative 1, which gives us y equals 2x plus 3. If I find that equation, y equals 2x plus 3 is this line that's passing through the first line we highlighted in red. So if I highlight that in blue, it would look like this. If this is a system of equations, again, what we care about, the solution, is the place where the lines intersect. So if we look, we're going to see that those lines intersect in a single point. With that being said, this has, number 25 has one solution. And then it told us to identify what the solution was. What are the coordinates of that point? The coordinates are -2, -1. So that's the ordered pair, like we said earlier, the ordered pair that makes both equations true if we substitute that x value and that y value in to both equations. All right, y'all, I hope this helps.